students, we are already start chapter number first, maths 1, that is the set chapter, and in that set chapter we are already learned the practice set 1.1. Then we are before start the practice set 1.2, whatever be the basic information you must be know, that information is first taken, and afterwards we are start the practice set 1.2. So the first point of this is types of set. So how many types of sets are there that we are going to learn? So this is the first type of set, that is called as singleton sets. So singleton sets means what? The singleton set means a set contain only one element, that is called as singleton sets. See, single means one, ton means element. So in that set they are having only one element, so that set is called as singleton sets. Are you understand? This is very simple to understand, that a set containing exactly one element, only one element, not greater than one element, only one element in that set, and that set is called as the singleton sets. Is that clear? So example, A having set, A having element 5, so it is singleton sets. Then B is the set of X such that X plus 3 is equal to 0. So what is this? X plus 3 is equal to 0. So it is the plus 3. So what is opposite of plus 3? Because you are doing addition. In addition, if number are same but sign is different, then the answer you are getting is 0. Okay, what I say, see, B is the set of X such that X plus 3 is equal to 0. X plus 3 is equal to 0. So this is the plus 3. So opposite of plus 3 is what? Minus 3. Okay, opposite of plus 3 is what? Minus 3. So why you are taken minus 3? Because one number are same but sign are different, then they are you are doing subtraction, and answer you are getting is 0. So here is plus 3, X is equal to minus 3, so I write here minus 3, minus 3 plus 3 you are getting 0. So here is only one element is there, which is that minus 3. So these are the two examples of the singleton sets. A having element 5, then B is the set of X such that X plus 3 is equal to 0. So what is the value of X that we can find out? Here is the plus 3. So plus 3 is opposite is minus 3. So X value you are getting single number, that is minus 3. So minus 3 plus 3 you are getting 0. So it is the singleton sets. Okay. So yeah, they are having so many examples of the singleton sets. So you can write that examples and so write it into your notebooks. Then another is that empty set. So another set type is the empty set. What is the empty set? Empty set means that set having no element. Empty set means that set having no element. That is called as the empty sets. A set which does not contain any element is called an empty set. Okay, and we are say a set which having no element, there is no single element is also there, no element is there, so that set is called as the empty sets. Are you understand? Singleton set means what? Only one element. Empty set means what? No element, there is no element, so that is called as the empty sets. A set which does not contain any element is called as an empty set. Okay, a set which does not contain any element is called as an empty set, or it is another way called as null set. Another way it is called as the null set. Are you clear? Empty set means what? Empty set means set which having no element. It is called the empty set. Null set means what? Mean null set and empty set meaning is same. Empty set, or it is called null set, means a set which does not contain any element is called as the null set or empty set. So it is represented by such a curly bracket. See, in curly bracket don't write 0. If you write 0, then 0 is the element. So my students, remember that, because if you write here 0, then it is not an empty set, it is singleton sets. So when you want to write the empty set, you are only show curly bracket such a way, and there you don't write anything. So it is the empty set symbol, or another way it is called phi. So 5 is empty set. A set which does not contain any element is called as an empty set, or it is called null set, and it is represented this curly bracket such a way, or phi. So example of this is A is the set of A. See, A is the set of A such that this line is called as such that A is the set of A such that A is a natural number, 5 is smaller than A and A is smaller than 6. So what they are said, A is a what? Natural number. Natural number means all numbers are positive. They are 1, 2, 3, 4, 5, 6. There is no. So here is, they are said the 5 is smaller than A and this A is smaller than 6. Is it possible they are having a number, natural number? Is it possible? No. What they are said this A is greater than 5 and this A is smaller than 6. So having such a types of number in natural number? No. In natural number there is 5, 6, 7. Means such a way they are increasing. And A is greater than 5. Okay, A is greater than 5. Answer, you are getting 6. But this 6 is greater than, but this 6 is smaller than 6. Is it possible? No. So it is a no element in this set. What I say, are you understand? A is the set of A such that A is a natural number. Okay, and A is smaller than, A is greater than 5, but A is smaller than 6. So there is no natural number in between 5 and 6. So it is a empty set. No element is there. So it is written such a way by curly bracket or such a way by 5. Another example. B is the set of X such that, this is called such that, B is the set of X such that X is a natural number. X is a natural number and X is smaller than, this X is smaller than 1. Okay, so natural number is started from 1. So there is no number which is smaller than 1 in natural number. Having their number? No, because 1 is the smallest number in the natural number, and they are said the natural number which is smaller than 1. Is it possible? No, there is not possible. So there is no element. So it is an empty set, and that can be write B is equal to 5, empty set. Are you understand why it is the empty set? See, I again explain if some of the students don't understand. B is the set of X such that X is a natural number, X is smaller than 1. So this X is smaller than 1. 1 is natural number started from 1. So there is no number which is smaller than 1. So it is empty set. Okay, and that can be shown by the 5. Then another is the finite set. So finite set are, finite sets mean if counting of element in a set terminated at a certain stage, the set is called as finite set. Means what? The element in that set we know, and where that set ended we know. So that is called as the finite set, because they are said terminate. Terminate means their endpoints you know where is completed. Such a set is called as the finite sets. If counting of element in a set terminate at a certain stage, the set is called as the finite sets. Example, A is the set 1, 2, 3, 4, 5, 6, 7. So the number of element is ended at 7. So it is a finite set. B is the set of X such that X is a day in a week. So we know how many days are there: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So here is the endpoint you know. So such a set is called as the finite sets. Are you understand? See, A is called a finite set because they are ended at 7. B is called a finite set because day of week we know and we can easily count it or we can easily say. So that two sets are terminated set. Their endpoint you know. So this is called as the finite sets. Another example. The above set A and B are finite sets because their endpoints we know, or where their terminate is infinite set. Infinite set means what? Infinite sets means a counting of element is never terminated. A counting of element is never terminated. That is called as the infinite sets. And finite means they are terminated. See, finite set, the counting is terminated. What difference are you understand? This set counting is terminated. This is called finite sets. And infinite set not terminated. Counting is not terminated. At which stage counting is stopped, we don't know. So that is called as the infinite sets. So infinite sets or infinite sets means a counting is not terminated. That is called as the infinite sets. See, the natural number p is the natural number set 1 2 3 4 5 6 dash dash dash. Where they are completed, where they are terminated, we don't know. Another, w is the set of x such that x is a whole number. So whole number is started from 0 1 2 3 4 dash dash dash. So where they are end, we don't know. So such a set is called as infinite sets. So this is the natural number infinite sets, whole number infinite set, integer numbers infinite set, real number infinite sets. So these sets are as the infinite set. And in Delhi's example, the water in the sea infinite set, the star in the sky infinite sets. Is that clear? So this is the example of the infinite sets. Then equal set. Two set A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. Means what? The A and B are equal set, but when it is called equal, whatever be the elements of A that present in B and whatever be the elements of B that present in A, that is called as the equal set. Are you understand in simple language? The element of A is present in element of B, total element present in element of B, and the element of element in set B having in set A, that is called as the equal set. That is, say here, see, A and B are equal set if every element of set A is in set B and every element of set B is in set A. That is called as the equal sets. So that can be shown A is equal to B. Example, see here. If A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, then verify A is not equal to B. Verify means, see, the element of A 1, 2, 3. So element of A 1, 2, 3, but here having the 4. So they are not a equal set, because in set A they are having 3 elements 1, 2, 3, but in set B they are having 4 elements. So the A set and B set, they are not equal set. So here is, we are say the 4 is not belong to A, because in set A 4 number is absent there, nothing number there. So 4 is not belong to A. See, this is the A, so this 4 is not belong to A, but this 4 is belong to B. So it is written, see, I already explained, this sign is belong to, so this 4 having in B, so I am right here 4 belong to B, but this 4 is not having in A. See, in A there is not having 4 number, so 4 is not belong to A. So they are, A and B is not equal. A and B are not equal set. Do you understand why not equal? Because the element are not same in both sets, simple way. So that is shown by A is not equal to B. Then A is the set of X. See, this is the A set. So A is the set of X such that X is prime number and 10 is smaller than X and X is smaller than 20. Means here is where started a number 11, 12, 13, 14, 15, 16, 17, 18 and 19. Because they are said this X is greater than 10. So X is greater than 10, 10 is greater than number 11. So 11, 12, 13, 14, 15, 16, 17, 18 and 19. Why not 20? Because it is smaller than 20. So up to 90. Then B set. B set is equal to 11, then 13, then 17, then 19. So this is the B set, 11, 13, 17, 19. You want to verify this. Okay, but what they are said prime number. So I'm just counted is the natural number. So if you want to write the prime number, then you can write this 11. 11 is the prime number. Then 13. 13 is the prime number. Then 17. 17 is the prime number. Then 19. 19 is the prime number. Why it is called a prime number 11, 13, 17 and 19? Because that number is divided by 1 and itself. They are not divided by another numbers. What I say, are you understand? The 11 number, 13 number, 17 number, 19 number, that number is divided by 1 and itself only. So they are a prime number. So we can check it. 11 is a prime number divided by 1 and 11. 13 is also divided by 1 and 13. 17 is also divided by 1 and 17. 19 is also divided by 1 and 19. So these elements, all the elements are present in B. See, A having A, B having, A having 11, B having 11, A having 13, B having 13, A having 17, B having 17, A having 19, B having 19. So the elements of A and elements of B, they are same. So that is called as the equal sets. Okay, so we can see the types of sets here. Then we will start the practice set 1.2. So we have already see the types of sets. So we are not taken in today's lecture only. We are not taken whole practice set 1.2. So today we are taken only 2 problems, and afterwards we are taken remaining problems in the next lecture. Okay. So practice set 1.2, question number 1 and 2. Question number 1. Decide which of the following are equal sets. What is equal set? Whatever be the elements of A that is having in B, and whatever be the elements of B set that is having in set A, then they are called the equal sets. Okay, so they are said decide which of the following are equal sets and which are not. Justify your answer. You must give your reason. Why not so? So A is the set of X such that 3x minus 1 is equal to 2. 3x minus 1 is equal to 2. So x is equal to what? 1. 3 1s are 3. 3 minus 1 2. Okay. So here is you get x value 1. Then B set. B is the set of X such that X is a natural number but X is neither prime nor composite. So which number is not a prime and not a composite? Do you know? The one, only one number is not a prime and not a composite. Okay, so that one number is not a prime and not a composite. Then this is, see, A value you are getting 1, B value you are getting 1. Are you understand how can you get 1? 3 1s are 3, 3 minus 1 2. Then here is they are said X is a natural number but X is neither prime or nor composite. So neither prime nor composite number is only 1. Okay, so here also we are getting 1. C is the set of X such that X is belong to N. C is the set of X such that X is belong to N and X is smaller than 2. So which natural number is smaller than 2? X is smaller than 2. So which is smaller than 2? 1. So here also C value you are getting 1. So each and every, if you are observe, is the set of X such that 3x minus 1 is equal to 2. So here is 3x minus 1. So x value you are right here 1. So see, 3x is equal to 3. Means how can I find out? Just see. This is the minus 1. So that minus 1 go across, it become plus. So minus 1 plus minus 1 go across become plus. 2 plus 1 3. So here we are getting 3. See, 3x minus 1 is equal to 2. So this minus 1 go across plus 1. 2 plus 1 3. So 3x is equal to 3. Are you understand what I say? See, 3x minus 1 is equal to 2. So this minus 1 go across plus 1. So 2 plus 1 3. So 3x is equal to 3. So this 3 is multiplying x, go across, divide. This 3 is multiplying x, go across, divide. So x is equal to 3 upon 3. So x is equal to 3 upon 3. So x is equal to 3 1s are 3. So x is equal to 1. Okay. So that a values, x value you are getting is equal to x such that x is 3x minus 1 is equal to 2. So 3x minus 1 is equal to 2. Minus 1 go across plus 1. 2 plus 1 3. So here is you get 3. 3x remain as it is. So 3x is equal to 3. 3 is multiply, go across, divide. So these 3 remain as it is. Divided by these 3 multiplying, go across, divide, so it is right as denominator. 3 ones are 3. So x is equal to 1 you are getting. Then we have solved the another problem. That B is the set of x such that x is the natural number but x is neither prime or not composite. So number 1 is not a prime and not composite. So my students, you must be remember that this 1 is not a prime and not a composite. Then C is the set of x such that x is belong to natural number and x is smaller than 2. So you want to find the value that natural number which is smaller than 2. So natural number which is smaller than 2 is 1. So here also you are getting 1. So A is equal to 1, B is equal to 1, C is equal to 1. So it is equal set. Here A, B, C are a equal set because they are having only one elements. Second problem. Decide whether set A and set B are equal set. Give reason for your answer. So first we write the A. A is equal to, A is the set of even prime number. So they are said only prime number, even prime number you want to write. Okay, even prime number. And B is the set of x such that 7x minus 1 is equal to 13. So you want to solve this. So even prime number is only one, that is 2. Remember my student, even prime number is only 1. Means if they are said you can write even prime number 0 to 1000, then there is only 2 is the even prime number. So even prime number is only 1, 2. Is that clear? So A value you are getting 2. Then you want to solve the B. So see here, B is the set of x such that 7x minus 1 is equal to 13. So 7x minus 1 is equal to 13. Minus 1 go across, it become plus 1. So 7x is equal to 13 plus 1. See, 7x minus 1 is equal to 13. So this 7x remain as it is. This 13 remain as it is. Minus 1 go across plus 1. So 13 plus 1 you are getting 14. 13 plus 1 you are getting 14. This 7x carry as it is. 7 is multiply, go across, divide. 7 is multiply, go across, divide. So x is equal to 14 upon 7. So see, 7x is equal to 14. 14 is remain as it is. 7 is multiply, go across, divide. 7 1 are 7, 7 2 are 14. So x is equal to 2. So you are getting value x is equal to 2. See, A value is also 2 and his B value is also 2. So they are equal set because they are having the same element. So they are equal sets. Are you understand my student what I say to you? So homework is only what the homework is write the type of sets, and with example write the type of set. And set 1.2 problem number 1